So today I'll be going over the question Tulip Mania for Midterm 12. This question is from the Spring 2022 Midterm 2, and it asks us to implement Flower Keeper, a function that mutates a tree T so that the only paths that remain are ones which end in a leaf node with a tulip flower labeled V. For example, consider this tree where only one path ends in a flower. After calling Flower Keeper, the tree only has 3 nodes left, the ones that lead to the flower. The shaded nodes in the diagram indicate paths that end in flowers. For this tree, where 2 paths end in flowers, the tree keeps both paths. For a tree where none of the nodes are flowers, the function removes every branch except for the root node. For a tree with only a single node that is a flower, the function does not remove or mutate anything. So we know that we want to be mutating the input tree so that its branches are kept if and only if they end in a leaf labeled V. The specs also show us that even if T has no paths that end in flowers, the root node should still be kept, which gives us a hint that we should stick to mutating the branches and avoid mutating the root of the tree itself. But we also have to remember that just because a branch does not have the label V does not mean that it isn't on the path to a leaf with the label V. For example, looking at the stock test, this branch has a label of I, but it isn't cut out because it's still along the path to a leaf with the label V. We can only cut the branch when we know for sure that it is not part of one of these paths, and we'll know that once we reach the end of the branch and it's neither labeled V nor does it have any branches of its own. In other words, we know to cut out a branch if it's a leaf that does not have the label V. We're trying to mutate the branches of the tree itself, which we can do using this list comprehension provided in the skeleton code. We can set t.branches equal to this new set of branches, B, for B in the initial t.branches, if b.label equals B, or not b.isLeaf. And this way we ensure that if a branch is on the path to a leaf with the label V, we don't cut it out. Going back up to this for loop, we know that we want to find a way to iterate across each branch of the tree and then the branches of those branches until we reach the end of the tree. We can do this by using this for loop provided in the skeleton code for B and blank. To repeat this process across the entire tree, what we can do is recursively call Flower Keeper on each branch, so we prune those branches as well by writing for B in t.branches, and then simply calling Flower Keeper on each of those branches by writing Flower Keeper of B. And there you have it. We successfully implemented Flower Keeper.